Hi everyone, welcome to the first lecture of this course on measurement and instrumentation. I am your instructor Ravindra. Let's first discuss about the course content before we actually move to the actual content of the or actual discussion of the course. Okay, so the total course is divided into 5 different modules. The first module, which is basically what we are going to discuss in first week, is the fundamental of measurement system. Okay. So here we will discuss, although the name suggests measurement system, but along with this we will also try to cover the basics of instrumentation. Okay. So all these things I have already mentioned this in the introductory lecture that they are interlinked to each other. Okay. So lecture 1 is dedicated, or week 1 basically is dedicated to fundamental of measurement systems. The week 2 to 6th week of this course is dedicated to analog meters. So we will discuss the fundamental building of analog meter and how it operate. Okay. So we will cover a number of analog meters in this module. The third module is on transducer. We will see what we will cover in this transducer week. Okay. So basically week 7 and 8 is dedicated to the transducer discussion. Okay. Then further we will talk about signal conditioning circuits in week 9 and 10. We will see the methodologies to condition the signals and basically why actually this is required. That will be clear from this particular module. Okay. And the final module, the 5th module, is on data acquisition system. So we will discuss that in more detail. If you see the lecture plans, the first week, as I have mentioned, is on fundamentals of measurement systems. In this week we will talk about a different type of measurement system and the characteristic of a measurement system. Okay. The characteristic include static and dynamic characteristic of the measurement system and various measurement uncertainty, loading effect, etc. Okay. We will start the analog meter as I have just mentioned in the second week, where I will first give you introduction about the analog meters, and then we will talk about different effects like electrostatic effect, magnetic effect, electromagnetic effect in analog meters. Okay. And then we will actually start discussing about the instruments based on these effects. Okay. The third week we will talk about the basic operating forces that are utilized in electromechanical indicating instruments. Okay. And once we understand these forces, it will be very easy for us to talk about the construction, I mean how these forces are generated in an electromechanical indicating instrument. So we will talk about the construction of electromechanical indicating instrument, and once we understand the electromechanical indicating instrument construction, we will further move ahead with the discussion on various voltmeters and ammeters. Once I introduce you to the world of voltmeters and ammeters, how some of the electromechanical indicating instrument can act both as a voltmeter and ammeter, or what changes in the construction we have to do to make a electromechanical indicating instrument a voltmeter to ammeter or vice versa, we will see in the subsequent weeks. Okay. The 4th week of this analog meter or in this course will be dedicated to PMMC, which is permanent magnetic moving coil kind of instrument, and moving iron and electrodynamometer kind of instrument. Okay. All these instruments are very crucial for this course. So week 4 is going to be very important. The rest of the devices like hot wire kind of device, thermocouple based analog meters, induction, electrostatic, rectifier type instruments, we are going to talk about all these instruments in our 5th week of the discussion. Okay. And rest of the measurement like measurement of resistance, resistance also in different range, low resistance, medium resistance and high resistance, as well as we will see power measurement and energy meters or energy measurements, and if the time permits we will also talk about frequency and phase measurements. Okay. So, this is what we are going to talk in the analog meter discussion. In the 7th week, we will talk about the transducers. Okay. So, basically we will try to talk about measuring two important parameters, which is temperature and the pressure. Okay. So, 7th week will be dedicated to the measurement of temperature and pressure using certain transducers. Okay. Then 8th week, as I have already mentioned, that we will be giving 2 different weeks for transducer. So, 8th week also will continue our discussion on transducers, and here we will target 2 different physical quantities, which are force and strain. Okay. So, once we understand this analog meters and transducers, we will talk about signal conditioning in week 9 and week 10. Okay. So, in week 9, we will talk about the instrumentation amplifier, which is very crucial for all these instruments, and we will also talk about different filters. Okay. So, once we understand this amplifier and the filters, we will move ahead with a discussion on AD and DA converters, and if the time permit, we will also talk about shielding and grounding techniques. Okay. Then the final module, which is data acquisition systems, we are going to cover in the last 2 modules, which is week 11 and week 12. In the week 11, we will talk about different digital meters and analog and digital oscilloscopes. Okay. We will also discuss about signal analyzers in this particular week, and finally we will talk about harmonic distortion, spectrum and logic analyzers, and programmable logic controller or PLC in the final week. Okay. So, that is how our course is constructed. Okay. And we will try to stick with the lectures in these weeks. Okay. So, I hope that you have understood the course syllabi. Okay. So, let us come back to our module 1, which is the fundamental of measurement system, and let us discuss with the most crucial word, that is what is measurement. Okay. And that is what this course is all about. Okay. Measurement and the instrumentation. Okay. So, measurement is actually, as the name suggests, act of process of measuring. Okay. Or you can say that the method or methodology to measure something. Okay. So, then what is measure itself? Okay. So, measure is to discover the exact size or amount of something. Okay. This measure word or measurement word we hear, I think, nearly every day in our house or in our workplace. Okay. Be it our own length or our own weight or the commodities that we purchase. Okay. Or if you are dealing with electrical equipments, the amount of current that your system is exposed to, or the voltage that you intend to supply, and all those. Okay. So, measurement and measure, of course, is the act or process of measuring, and measure is to discover the exact size or amount of something. This something in our case in this course will be mostly in terms of electrical parameters. Okay. So, basically this measurement is done by comparison between 2 different quantities whose magnitude, of course, one whose magnitude is unknown and to a predefined standard value. Okay. So, that is how a measurement is basically done. I mean, this is the way of direct measurement. We will see that if there are other ways of measurement also. Fine. So, then all this measurement, you measure your length or you measure the weight, everything comes with a unit. Okay. So, if you measure the length, it must be in centimeter, millimeter, or in meter, something like that. Okay. And sometimes this unit plays very important role while defining certain parameters. Say for example, if you are measuring highway, you will not measure in millimeter, right? Similarly, if you are measuring your length or your height, you will not measure in kilometer. Okay. So, unit is very significant or very important parameter while measuring certain quantity. Okay. So, unit is a standard quantity of a physical parameter adopted by convention. Okay. So, and it is used as a reference to express the magnitude of other quantity of the same kind. Okay. And if you talk about the physical quantities like length, you have a standard unit in meter. Okay. Similarly, mass is defined in gram or kilogram, time in seconds, current in ampere, temperature in Kelvin, luminous intensity in candela, voltage in volt, okay, something like resistance in ohm, like this. Okay. So, all this quantity can be measured and have certain unit. Okay. So, in order that the results of the measurement are meaningful, there are two basic requirements, okay, for the measurement. Okay. So, the two requirement of measurements are the standard used for the comparison purpose must be accurately defined and should be commonly accepted. Okay. So, like say for example, if you are measuring the height of a person, you have a standard tape. Okay. So, that is something which is commonly accepted. If you take a rope and if you try to measure and then you try to send that rope to the some agency that okay, I have measured the person's height using that rope, it may not be accepted. Okay. So, the rope is something not commonly accepted. Okay. The tape or the unit that tape is giving to you is something which is accepted. Okay. So, the first requirement for measurement is the standard used for comparison purpose must be accurately defined and should be commonly accepted. The second requirement is the tool or the apparatus that you are using and the method adopted for the measurement should be provable. Okay. So, the tape that the person has used to measure the height, okay, the other agency where you are sending the data should also have similar tape, okay, for that measurement. Okay. So, universally if you see the centimeter or millimeter scale on any kind of scale is same. Okay. So, the method that or the tool that I am using is well adopted across the globe and is provable. Okay. Similarly, if you talk about the terminology in terms of current or voltage, okay. So, you have a battery and if you are measuring the potential across it, say if it is 5 volt, okay. So, you are telling that the voltage is 5 volt, okay. And if you have say you have used certain voltmeter to measure this voltage, okay. Now, if you send this battery to anywhere in the globe, it will only measure the 5 volt. Okay. So, the method of measurement by this voltmeter is universally accepted and is proven all across. Okay. So, this is the second stringent requirement for the measurement. Okay. Let us try to understand that where these measurements are required in more systematic way or in more engineering way. Okay. So, consider a case of a control system. Okay. In a control system, for example, in a controlled process parameter, you have controlled process parameter. Okay. So, you require the measurements or the measurement tools to monitor the processes and the operations. We will see this in more detail. Okay. You need to control the processes and the operation. So, you need to monitor the process and operation as well as you need equipments or measurements to control these processes and operations, and finally, say for certain experimental engineering analysis you will need this. We will see this with certain example. Okay. Say what do you mean by monitoring of process and operations? So, measuring devices is being used to keep track of certain physical quantity, maybe it is temperature or maybe it is pressure. Okay. So, you have equipments or tools or instruments basically to monitor the processes and operation. Okay. So, if it is a furnace, for example, if it is heated, okay. So, you have a thermometer to measure the heating process. Okay. And say you have a pressure gauge to measure the pressure or barometer to measure a certain pressure. Okay. Similarly, for controlling the process and operation, you should have a feedback control system, which is also based on the measurement. Okay, so you measure the output, okay, and you try to correlate with the input, and you see that if the variable is increasing to the threshold value, you should cut the output, or you should fix it to the controlled value, which is the desired value. We will see this with the example of a control system. That will be much better. Okay. And the third that I have just mentioned was the experimental engineering analysis. Say like in a modern day, you need fuel meters, speedometers, okay, electric meters to measure the day-to-day engineering equipments. Okay, so you have speedometer to measure the speed of your vehicle or speed of a motor or whatever. Okay, you have fuel gauges for monitoring of the fuel of a engineering tool, which is a automobile. Okay, and you have different electrical meters. Okay, so let us see one example of control of process and operation, and by this control system, I think it will be more clear that why the measurement and instrumentation is very crucial. Okay, so let's see this with the example of a control system. So you have input energy and or material fed to a process. Okay, then you have a controlled variable, and you have a measuring instrument place over, which is fed to a controller. Okay, and then you have final control element, and this feedback is completed over here. Okay, so let us try to see each and every component of this control system in little detail. Okay, so first is input energy or material. Okay, so this is what basically you feed into the process. Okay, it can be say a certain raw material, it can be fuel, or it can be voltage, it can be certain kind of fluids that you give to your into the process. Okay, so basically what it is doing is it is providing the necessary energy or resource for the process to operate. Okay, so the second part is you have fed this input energy to basically the process. I will come to the disturbance later on. Okay, you have fed it to the process itself. Okay, so process basically is the physical system or operation which is being controlled by this control system. Okay, so this can be a simple heating of a furnace, or say pressure in the tank, or speed of a motor, or flow of a pipeline. Okay, the process transforms the input energy or the material that you have fed into a controlled variable, which is basically your output. So the controlled variable itself is a output. Okay, now this is the quantity. The control variable basically is the quantity we want to maintain at a specific value. Okay, if the process is related to temperature, say we want to keep the furnace temperature say at 100 degrees Celsius. Okay, so that's why I have named it as a controlled variable. The output is called controlled variable because this is the quantity actually we want to maintain at certain value. Okay, so like temperature, I have just given an example. Okay, so then we have the output is fed to a measuring instrument. Okay, this is how your instrument comes into picture. Okay, now this device measure the current value of the controlled variable. Okay, so it gives you real time value of the output. Okay, so like if you have raised the temperature of this furnace, I am calling this process as a furnace. Okay, to increase the temperature. Okay, now say if you have raised the temperature of this furnace at say 10 degree Celsius per minute. Please note that if the furnace can reach to 900 degrees Celsius, you cannot directly switch it on so that it reaches to 900 degrees Celsius. It is done through a controlled process. Okay, so like I have kept it like 10 degrees Celsius per minute. So this controlled variable, the output through the measuring instrument measure the real time temperature that this process is generating. Okay, it sends the measurement signal basically to the controller along with the measuring current value. So, the output of this measuring instrument is fed to the controller. Alright, the controller basically is the brain of this control system. Okay. So, it compares the measured value from the measuring instrument with the desired value, which is basically the set point. Okay. So, I have set the temperature to be 100 degrees Celsius. So, the controlled process or the control system here should not allow the temperature of furnace to rise beyond 100 degrees Celsius. Okay. So, the controller compares the measured value from the measuring instrument with the desired value, which is the set point. Okay. So, if there is a difference, the controller generates a corrective signal. Okay, or it takes care of the error. Okay. So, this is the desired value of the controlled variable is basically your set point. Alright. Then this is the output of this controller is fed to a final control element. Okay. So, this device acts on the process to correct the error which is or the difference that the controller has generated. Okay. The final control element can be a simple valve, it can be a motor or a heater or a pump or something. Okay. So, say if this output, the controlled variable has not reached to 100 degrees Celsius and I am continuously measuring this with a heat measurement device. Okay. This controller will tell this control element, which is in this case a heater, okay, to increase this temperature little more so that this output is set to 100 degree Celsius. Fine. So, this is a basic building block of a control system, but then we have two important parameters that we have not discussed, that is the disturbance and the set point in this control system. Okay. So, external or internal changes that affect the process, such as change in say ambient condition or pressure condition or load changes actually have impact on the process itself, and that is why if you see this disturbance is directly connected to the process itself, right. So, the control system works to minimize the effect of this external disturbance. Okay. And the set point, I have already mentioned that this is a target or the reference value that the system aims to maintain. Say for example, we have taken like 100 degrees Celsius for the furnace to achieve, but so if you see this controlled process or control system, you need measurement at each step. Okay. So, if you see the holistic view of this control process, you need this output monitoring in real time, which is fed to this controller and which is fed to the control element. So, you need continuous measurement of the output. So, you need measurement continuously by the instrument that is placed. Okay. So, I hope that the requirement of a measurement system is very clear to you. Okay. Now, let us talk about the elements of a basic measurement system. Okay. So, the basic measurement system can have following parts. Okay. First of all, you need a measurand, which is the physical quantity you wish to measure. It can be a simple temperature or it can be a pressure, or you have just seen one example that measurand was temperature. Okay. So, you need first measured variable or measurand. Okay. Then the measurement system has sensor as its important part. Okay. Then it has a variable conversion elements. Okay. It has a signal processing element. Okay. And you have signal transmission element, and then you have signal presentation or recording tool. Okay. So, measurand is the physical quantity that you want to measure, which is basically fed to a sensor. Okay. Now, this sensor produces output as a function of the measurand. Okay. So, for example, this is a temperature and this is a sensor which measures the the temperature, okay, it will produce certain output in terms of electrical signal, okay, say change in current or change in voltage, all right. Then you have a variable conversion element which convert the sensor's output, the output that sensor has fed into it, into some useful signal format, okay. Say bridge circuit for example, okay. So this was the signal that sensor has given is fed to a conversion element which convert this data useful for further signal processing, okay. Then you have a signal processing unit which improve the signal quality, okay, for further processing, and basically these signal processing units have different amplifiers, filters, etc. Okay. Then you have the signal transmission, okay. This signal transmission of this processed signal can be electrical or optical in nature, okay. Then you have this signal transmission element which gives data to the signal presentation or recording part. Oh, so this signal presentation or recording that we will also cover in this course basically display the recorded data, or it can also be used to control the data, like it can be a simple oscilloscope or any other displaying unit, okay. So, I cannot say that sensor itself is a measurement system. It is a part of measurement system, and this complete your measurement system. So, measurement system has sensor, variable conversion element, processing unit, transmission unit, and a recording unit or a presentation unit, okay. So, this is how measurement system actually looks like, okay. So, once we understand that why this measurement is required and what are the elements of measurement system, I think we can move ahead with the methods of measurement, okay. So, the methods of measurement can be broadly classified into two different categories, okay. One is direct method of measurement and second is indirect method of measurement, okay. So, let us try to understand the difference between the direct method of measurement and indirect method of measurement, okay. So, in the direct method, the unknown quantity which is also called a measurand is directly compared against a standard value, okay, and the result is expressed as a numerical number and a unit, okay. The standard in fact is a physical embodiment of a unit, okay. So, the example of direct method can be measurement of say length of a person or length of a cloth with scale, okay, and the unit can be some numeric parameter say 5, okay, along with a unit which is say meter, okay. Similarly, measurement of resistance by ohm meter, again it is represented as a numeric unit say 5000, okay, and a unit like ohm, okay. Similarly, measurement of voltage and so on, okay. The second method is the indirect method, and as an engineering student we will be utilizing these methods regularly, okay. So, indirect measurement is measuring other quantities, required value is determined by certain mathematical relationship rather than measuring it directly, okay. We need this kind of measurement, indirect measurement regularly, because measurement by direct methods is not always possible. Sometimes it is not feasible and sometimes it is also not practical, okay. So, we will use this method regularly. So, for example, measuring length of a say highway, okay. So, you cannot have say the highway is say 500 kilometer long, you cannot have a tape coming from point A to point B which can give you a size of 500 kilometers. So, you can have, so smartly what you can do is you can start a vehicle at a constant speed. If you drove it to this point, okay, if you know the velocity, you can calculate the distance between the point A and point B, okay. Similarly, the measurement of volume is usually done by measuring the mass and the density of the liquids. As we know that volume is given as mass by density. Okay. Similarly, the measurement of speed is done by measuring the distance that you have covered by the time that you have taken to cover this distance. Okay. Similarly, measurement of temperature, sometime it gives you output in terms of resistance change or resistance values. Now you have to understand that this resistance value can change against what temperature change. Okay. So these are different methods of indirect measurement. I hope that when this course will progress, you will learn this measurement, maybe it's direct measurement or indirect measurement in more detail. Okay. So thank you for your attention. We'll meet again in our second lecture with some more detail on measurement and instrumentation. Thank you.